Alright, so here's a spiel about laws of cosine, which is just one law reordered. So this is the basic form of the equation. C squared equals a squared plus b squared minus 2ab cosine c. Looks big and scary, it's not very difficult to use. All the lowercase letters a, b, and c, they're all just the side lengths of the triangle. And then uppercase C, or all of the uppercase letters in the equation, which right now there's only C, but it could be any of the other variables, A, B, or C. But the uppercase letters are the angle measures that you know, or the angle measure singular that you know in the problem, which in this form of the equation, C. But if you translate it into this form of the equation, which you can do just as easily, because A, B, and C are arbitrary. You can assign them as you wish. But if you want to find the angle for A, then you just create the equation like this. You just need to make sure that whatever's on this side, the equal sign, is also what is inside the parentheses next to cosine, and everything else fills in these spots right here. Also, the equation can be reordered to find out the angle much easier if you just move cosine of c off to its own side and then reorder the equation like this. And that's just some basic algebra if you need to do it on the fly, which you shouldn't need to because this is also in the data booklet as this is. Now I'm going to apply that to a question. And the question I chose is question 1a from review set 9b. And it's simply determine the value of x of this triangle. Note this triangle is not exactly what they show in the book because I'm terrible at drawing, but this is the general idea, and the side lengths are correct. Alright, so the first task you got to do is you have to assign sides variables. And since we're trying to solve for this angle, it's always best to just assign this side C, because that's the equation they give you in the data booklet, that one. So it's easier just to keep C as what you're solving for. So that's C, and then A and B are arbitrary. You could have switched them if you really wanted to. It'll give you the same answer so long as you're consistent throughout the problem. Alright, so now that this side is C, that means that the angle opposite of it is uppercase C, which is this one, which is the one we're solving for, so that's nice. So first, I just take the equation, which is this. This equation's in your data booklet, and it's incredibly useful if you're trying to solve for an angle like we are right now. And it's really simple. Now that you've assigned all of the sides letters, you just plug in. So since A is 13, I plugged in 13 there. Since B is 19, I plugged in 19 there. And since C is 11, plugged 11 in there. Same on the bottom. And then I just began to solve through until I got to this fractional, or this decimal answer. But it's not the answer. Because I still have to get this cosine out of here and get C by itself. So, another thing. This dots here, just because it's a repeating decimal. So it's best if you just leave it as a repeating decimal in your calculator and then just write down a few digits of it on the page. You'll get a more accurate answer if you just use the answer key on the calculator to calculate the next step, which is taking the inverse cosine of the value you got up here. And then if you do that correctly, you'll get 34.1 degrees. And make sure your calculator is in degree setting, because mine wasn't, and I got this wrong at first. But this is the right answer, so have fun.
The law of sine states that triangle ABC with sides A, B, and C units in length will be opposite the angles A, B, and C. The law states that sine of A over A equals the sine of B over B, which equals the sine of C over C. This can also be reversed to be A over the sine of A equals B over the sine of B equals C over the sine of C.
Alright, so we're going to use the sine rule to figure out
the angle BAC given this triangle, so that we know that A equals 14.6, so 14.6 over the sine of A equals B, which we know is 17.4 over the sine of B, which is the sine of 65. Sine of 65 degrees. And from here, you're going to need to use your calculator and figure out that the sine of, or 17.4 divided by the sine of 65 equals 19.2. And from here, you are going to divide 14.6 by 19.2 to isolate the sine of A. And with that, you get 0.76 equals the sine of A. From here, you're going to do the inverse sine, and once you get that, you get A equals 49.5, and therefore angle BAC equals 49.5 degrees.
Good. Alright, so I'm going to talk about some right angle trigonometry. So this is where we use SOHCAHTOA, and so SO goes with sine, and in this triangle, if you're trying to find sine, it would be opposite over hypotenuse. So the opposite, for say, if you're trying to find the angle B, you go across, so opposite would be the B, so it would be sine of B equals opposite B, so it would be B over the hypotenuse, which is A. So to find the sine of B, it would be sine of B equals B over A, as that is the opposite over the hypotenuse. And you would do the same thing for C, where it would be sine C, which equals C and over A. It would be the two sines, and since you already know the angle of A, you wouldn't need to use any sine rule there, because as you already know the angle. And these right angle forms are used to find unknown angles, like for the angles for B and C. The CA part, so CAH, goes over cosine, which is adjacent over hypotenuse. So for B, the cosine B equals the adjacent, which is C, and the hypotenuse, which is A. So cosine B is C over A, while cosine C would be, adjacent would be B over hypotenuse A. And then TOA or TOA goes over tangent. Tangent, which is 10. So for B will be tangent of B would equal the opposite, which would be B, over the adjacent, which is C. And then same sort of thing for C, where it would be C over B. And those are signs for right angle trigonometry. This can only be used when you have a right triangle. And then as for a practice problem, let's say Rufus, we're trying to put a ladder on it to get to the top of a roof. You wouldn't want to know the length of the ladder required and how far away he'd want to put it from the house. So the height of the house would be 5 meters and the angle to the house is 45. So I need to find the length of the ladder, which I labeled as X. We look at it and find the easiest way to do it, which you look at your SOHCAHTOA. Figure out that since that's the opposite and you want to find the hypotenuse, you would use the sine rule. Not the sine rule, but you want to use sine. The sine of 45 degrees, it equals 5 over x. And you would solve this out, and you'd have to use your calculator. And with the calculator, you would always want to make sure to put it in degrees, unless you're doing it in radians. So x equals 5 over sine of 45. This would be the more exact answer, but in this case, if you go with 7.07 and labeled as 7.07 meters, so the height of the ladder is 7.07 meters. And now to find the length from the house to the bottom of the ladder, you would use you'd want to use tangent, and so that you don't have to use the value that you found for x in case you did a mistake in there. So that would be tangent of 45 degrees equals 5 over y, which would be y equals 5 over tangent of 45. And since tangent of 45 is just 1, and so for that one is y equals 5 meters. Always be sure to label your answers.